The tough part about math is that there's lots of different ways we can go to solve a problem. Right, so I'm going to offer one way to solve this problem. I'm sure there's other ones that I haven't considered, so feel free to message me if you've got an idea, and I can help you check it out. But I'm seeing we've got cosine and sine, and two separate equations. They're parameterized by theta because they both share theta as a variable. So to eliminate that variable theta, let's consider something that we know back from pre-calculus, from trigonometry, that the square of sine plus the square of cosine is 1. I like to think of it like this instead of having the square here, but that's not the traditional notation. Sine squared plus cosine squared equals 1. And note that you could write this regardless of this equation up here, right? If you square some variable, if you do sine of some variable and then square it, and add cosine of some variable squared, that should always equal 1. That's one of our Pythagorean identities. So if we could just get cosine by itself and just get sine by itself, then we might be able to make a substitution and make just one equation instead of two, and therefore we'd eliminate the parameter theta. I'm getting closer to getting cosine by itself, so now I've got x minus 8 over 5 equals cosine theta, and then getting sine theta by itself over here is pretty easy. So if we make that substitution, then this is y plus 1 squared plus x minus 8 over 5 squared equals 1. And hopefully this looks familiar. If it doesn't, that's okay, I can tell you. This is the equation, this is close to the standard form of an equation of an ellipse. Remember, the equation of a circle that's centered at 0, 0 is just an x squared plus a y squared, and it equals some radius. So this could be 16, that it equals the square root of a radius, I should say. Or sometimes we write it as some value being squared. This is the equation of a circle. You can modify it a bit by dividing these terms by some value, and that either elongates or contracts the ellipse. Those values can either make it be a long ellipse or make it be a narrow ellipse, depending on what those values are. So that's what we have going on here. Okay, this is an ellipse. We should rewrite it just a little bit more. You can look up. You can just Google search standard form of an ellipse to see what I'm doing here. And usually x comes first, but this is 5 squared in the denominator. And so what this tells us is that the center of our ellipse is at 8 on the x-axis and -1 on the y-axis, because standard form of an ellipse has this for the standard form, y minus some k. So this is like minus a -1. So that's why I'm going down to -1. This is the center of our ellipse. The horizontal axis is its length is determined down here, so it's 5 units to the left. It's 5 to the right. And then the vertical axis is going up 1 and down 1 from the center. So here and here. Hopefully that's enough to choose our graph. But if you're unfamiliar with what we just did there, you just want to Google search some information about standard form of ellipse. We'll actually be checking that out a little bit more in the coming sections.